Hello everyone, welcome to this video. My name is Amir Senahri. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how we can monitor the urban built-up areas using Google Earth Engine platform and valuable product there. Let's go to the code editor environment in the Google Earth Engine platform. In this session, same as the other tutorials, I'm going to use JavaScript language for the programming or scripting in the Earth Engine to extract desired information. So, in the first step, same as other tutorials, we need to identify the region of the interest through the drawing tools available here. So I'm gonna select a part of my own country, Iran, and also as in this tutorial, I'm gonna have focus on the built-up areas in the urban structure. I prefer to select a region including urban structures and buildings. So, for example, the biggest city in Iran is the capital or Tehran, and now I'm gonna show you how we can monitor the built-up changes or built-up growth in this region of my own country. So first we need to select this region. For example, I select this region mostly covered by the urban area, Tehran and Karachi together. So in the next step in the programming, write map.centerObject to have focused on the geometry that drawn, and in the next step through the search places and dataset, you need to go to the browse data catalog, and there through the desired tag you can search your desired data here. Here, according to the tags and keywords, you can find your desired data and products. For example, I'm gonna see how many for example products available regarding to the urban area. So here I'm using urban keyword, and we have 18 dataset related to the urban area. Go to the urban and you can see that the various products available here that you can use it for the urban studies. Some of them for urban heat island, some of them for population, some of them for the settlements, and some of them related to the impervious surface. But here GHSL is a product about global built-up surface from 1975 to 2030. That is very valuable product helping us to do the urban built-up monitoring over the 40 years ago. And also now I'm gonna use this product in this tutorial to show you how we can do this monitoring technique and extract the built-up maps for each year separately. So here you can see this product is available with 100 meter spatial resolution, and dataset availability clearly shows this data available since 1975. Although we are in 2024 now, but this product has some predictions about the future, such as 2030, that give you a perspective about the future condition. So, and here, if you want to have access or if you want to use this product, remember to cite the reference of data, and also here I'm going to show you how we can use this product and extract the information in the Earth Engine platform, and also its reference link, reference website, and also some description here available helping you to get more information in this regard. So, and now just copy the product title and paste it in the search places and data set. Here you can see the GHSL various product available under this title, but the first one referring to built-up surface area since 1975 to 2030, consider it for us, and now import it into the code as an image collection. In the next step, we need to call GHSL data, call the GHSL product. So I'm setting a title just to mention what I'm going to do in this part of programming. So make a new variable, for example, GHSL equals to assign image collection to, and then we need to set a filter bound because these products extracted from the Landsat and Sentinel products with this framing structure, we need to set filter bound for them. So, and then through the filter bound, I want to bounding my data to the region of the interest. In the next step, just print the GHSL variable to see how many elements available under this collection. You can see that 13 elements available here. Since 1975, for each 5 years, we have one built up map helping us to see the built up areas without applying any indices and also without further calculation. Just you can call your desired data, select the appropriate bands, and also do the visualization. It's very good and valuable product because most of the time to separate the urban area from the other regions, we are dealing and struggling with the various spectral indices, and also there are lots of errors in our estimations. Maybe it's too hard to find an appropriate spectral index to differentiate the urban areas from the rest of the region, and such kind of products helping us a lot in this regard. And also without doing any calculation, we can have access, use them, and get our desired information based on the urban area characteristic. So, and as you can see, for each year, two bands available here. One of them built surface and another one built surface that's referring to non-residential built up per person. And as you can see, two bands is available. The first for residential area and the second one is related to non-residential built up surface. And also in each pixel, meaning that, for example, built surface, each pixel showing the area of built up area or residential area according to the square meters. And now I want to select the first band for the residential area, copy and paste it here. For example, now just through that select, we want to select the desired band here. Its name is built surface, and when you run the code, you will see that only the first band selected here. And two bands available here, that is a prediction for the future. The first is 2025 and the next one is 2013. That is very valuable things in the such kind of studies. So in the next step, we want to do the visualization to see how the urban areas highlighted in this product, because it's very amazing thing, and we want to see its actually its accuracy and compare, and also you can compare it with the maps available through the Google satellites. And here just type map.add layer for the visualization process. That is one of the popular parts in the Earth Engine platform. But remember that we want to do visualization in Google Earth Engine just to check the results. The final visualization for making a layout and putting them in the papers would be better to bring this data into the ArcGIS Pro software and make an appropriate layout for the papers. And here we aim to use map.add layer just to check the data and also see how the value changes. That's it. And also we don't like to get the final export and make a final layout here, because not enough tools available for making high quality layout in the Google Earth Engine platform, because Earth Engine is specifically useful for analysis, calculations, processing, and for making layouts would be better to bring your data into the ArcGIS Pro actually. So map.add layer, GHSL, and then as it is an image collection, we need to convert it to a stack bands, including all to a stack layers, including all bands together collectively. And here through the .2 bands, you will be able to make a layer stack including all bands together, and then I'm gonna clip it based on my region of interest, that is geometry. And for the next step, I want to leave the visualization part empty, and the layer name is GHSL products, and end using false, we are avoiding automatic loading of final map because reduces the speed of processing. Would be better that you choose when the final result shows in the display. Run the code, and now in the layer setting you can see the GHSL product is available here. Go to the layer setting, check the one band grayscale style, and you can see the built-up surfaces for residential area available since 1975 to the 2030. It's very good. And maybe you asking why it is not yearly, because as you know, the urban development is gradually happened, and also it doesn't have a fast speed, and also we can see the urban growth or urban development more realistic and much better with 5 years frequency and 5 days interval, actually 5 years interval or 10 years even. So for example, I'm gonna see that what was the urban area in 1975, and here through the enhancement using 90% increase the contrast, and all the values showing in this band actually showing a range of areas of built up areas from the for example from minimum to maximum, so per pixel. And now you can see that, use the apply and check it on, and here you will see that the extent of Tehran in 1975 was like this, but now it grows a lot, and now you will be able to compare it with 2020 to see that how much the urban area changes over the last years. And now you can see that it's growth a lot, and new built up areas added to the different regions, and also it's very helpful and interesting things to do the visualization and also compare the urban growth here. And when you select a pixel in this image, you will see the area of residential built up surfaces in this pixel from 1975 to 2013. And also there is an outlier value 28 for 2018, that's showing that maybe something is wrong in this product for 2018, and maybe we will have some kind of error in this year. And now to check it more, let's try with 2018 image, and as you can see it's highly noisy, and unfortunately I think it doesn't have valuable information for 2018, and you can ignore it from the processing because the built-in problem that is in this product, maybe it is under improvement, I don't know. But for now 2018, in the date I'm working on this product, 2018 has false information, and we cannot rely on 2018 values. So back to the tutorial, and now in the next step I'm gonna show you how we can get the total area of built up surfaces in 1975 and 2020, and we can compare it easily because it's very valuable things. But before that, I'm gonna show you how we can get export from all images together for this region. It's very simple things. Just make a new variable as stack layer equals to, now I want to get all GHSL elements and throw the dots to bands, converting them into a stack layer. A stack layer is a single layer or single image including multiple bands. For example, when I print stack layer, you will see that in the right panel we will have one image with 13 bands, and each band showing information only for 1 year. So in the next part, we need to get export from this stack layer. Just use export dot image to drive. Sorry for the problem here. So, and export that image to drive. You will see here we have a couple of arguments. As you if you check my previous tutorial, almost in all of the tutorials I told you how we can use export that image to drive to get the export. So one of the main arguments available here is image. That image we want to get export is a stack, and just clip it according to the geometry that is already defined by the drawing tools. And the description refers to the name of output file. It is urban stack layer, for example, and the region of interest equals to the geometry we have identified. And the scale is very important. In the data description mentioned that the scale of this data or spatial resolution of this product is 100 meter. In the code, when in each part of the code that you need to import a scale value, you must aware that 100 meter is an exact value that you should set for the scale parameter. So in the scale, set 100 meter, and the next is maximum pixels. The max pixels that you can get export for each image equals to 1E13, and the next is the folder that you want to save this data in. For example, folder name for me is the test, and also you can choose any other names that you like. And CRS refers to the coordinate system. You can get the coordinate system of original data through the .getinfo.crs. .getinfo.crs. Get the coordinates, getting the coordinate system of data, and attach it to the output. And this is very important, because if you don't set the right coordinate system, you cannot combine this data and products with the other shapefiles or data you have for your study area. So, and also this is a simple step. This is a simple step for getting export. After running the code, in the right panel you will have urban stack here. By clicking on run, the process of saving in Google Drive started, and once the process is completed, the tab return to the blue color, and then you will be able to download it from the Google Drive. So now there is something wrong here. For example, mentioned exported bands must have compatible data types. Sometimes such kind of errors happen when you want to get export from a stack in the Earth Engine. When you face or encounter with such kind of error, would be better to set that float at the end of the code, at the end of the stack layer, such as I have done. And now again click on the run and run again. Now the process is started again, and also I think we don't face with the previous error again. And also, but we can continue. If any kind of errors occurred again, we can back and check the error, and let you know how we can solve this issue in the exporting parts. So for the next step, and now you can see that it is completely done without any problem. And then throw open in Drive, you will go, or you will navigate to the address in the Google Drive, and then you can download it and open it into desktop softwares you are working. In the desktop softwares, it could be ArcGIS Pro or QGIS. And then, so in the next part, I'm gonna show you how we can get the total area of uh, built up for residential areas in 1975 and 2020, and how we can compare these information together. So it's very simple. Now I'm gonna set the title for different parts that help, because I missed the description here, and this kind of descriptions helping you to know what we are doing in each part. And sorry for the my mistake to adding titles for different parts. So visualization, this is for visualization part, and also the stack layer. Make a single layer for bands, and the final part related to getting export. Export the stack layer. Yeah, just like that. So in the new part, I'm gonna to calculate the area of residential area. Calculate the area of residential area. Residential pixels. Yeah. So first we need to select 1975 image in the final results. So when you print the GHSL products, GHSL is an image collection. There is something wrong, because GHSL, yes, the name is wrong, GHSL. So printing GHSL product showing 13 elements is available, and some properties also we have for each year that you can see. Through the system index we can select a specific year for the processing. So for example, I'm gonna select the image for 1975 according to the system index equals to the 1975 or year of image. So make a new variable, for example urban 1975 equals to from GHSL product dot select. From GHSL product, as I'm going to select based on the properties, I need to use filters here. Dot filter earth engine dot filter dot equal. Please select that image in which system index in the properties equals to 1975, and then print the result to check the code. And a new image collection is produced but with 0 elements, showing that something is wrong in the code. Maybe 1975 could be in a string format, I don't know. Let's try again. Here check the properties name. The properties name is the system index. Yes, there is system index here. Try it again. Still we have that problem. So we need to check different things to find the way to find the reason of the problem. Let's try with a string format. Yes, now it works. Although here 1975 is a number, as you can see, is a number, but its format, it's not a real number. It's based on the string. And that's why when we turn the 1975 to a string, now it works, and now you will have a 1975 image that could be used for the next step processing. So what the problem is still the single element has image collection format. To convert it from image collection into an image, you should use .to bands. As I mentioned earlier, .to bands helping us to convert an image collection to a single image, an element will be converted to the bands. And as we have one element under this collection, it's converting that image to a file with a single band. Now run the code. Now you will see one band, one image, and that is for 9075. So, and in the next step, we want to calculate the area of the total area of residential regions according to the pixel value. So, as urban residential area in the urban region already identified in this product, no need to set a threshold to differentiate the residential area from non-residential area, because and also we have the area of residential area in each pixel. Just we need to get a sum from the available areas in the pixels. It's very simple and easy in the Earth Engine. Make a new variable, the area 9075 equals to, here, get urban 1975 dot reduce region, and now here some arguments should be imported here. The first is the reducer, that is the most important one, Earth Engine.reducer, as we want to get the total area and we need to get some of the all areas in the pixel. Reducer.sum will be used here. Reducer.sum, and for the region that is selected and identified as geometry, and a scale is equals to 100 meter. It's very important, 100 meter, and we want to get the area values from the first item available in this variable that get 0, and finally we want to convert it to a number format from a dictionary. So write print a residential area for 9075 equals to, so the area, the value including the area, actually area 9075. So here and also here the area of residential regions in 9075, but the problem is the format is based on the square meter, and through the, for example, some sort of conversion, if we convert it from a square meter to the square kilometer, you will have a smaller value. If you don't know how to convert the units together, it's very easy. Just type something like that, a square meter in the Google to a square kilometer. It's very easy, and also you can convert your area, and also you will see the equation. If you divide the square meter value to 1 million, and as you can see here, then you will have the square kilometer for the results. So just here, for example, Earth Engine.number, the final value dot divide to 1E6 or 1 million. And now you will see that the residential area, the residential pixels area totally is 225 square kilometer, and now we can add a square kilometer here in the 9075. In the next step, if you want to get the area for 2020, again it's very simple. Just copy all the previous code and paste it with the minor changes. For example, urban 9020, now in this time it is urban 2020, same product, same filter, but this time we will have 2020, and then new name, instead of 9075 we will have 220 2020, and again the same reducer, same geometry, same scale, but this time for 2020, and the final result will be for 2020. So you will see that the increasing area of the area of residential regions from 225 square kilometer to around roughly 400 square kilometer over the 40 years, according to this product that we have. And also maybe you want to do the time series for the, maybe you want to have the area variations for each year. It is also possible in the Earth Engine. Now in the new section, I'm gonna show you how to calculate the area for all available years. So here it's very simple. All the years available under GHSL variable, and also just we need to write a time series chart to make a time series chart and get the sum of the residential regions for each year. So just like that, print user interface dot chart image dot series. Instead of image collection, you will have GHSL product, the variable including the all years, and then instead of the region, we have the geometry instead of the reducer, as we need to get the total area and the area of a residential and the area of residential regions already included in the pixels. Just we need the sum reducer, or reducer.sum, Earth Engine.reducer.sum here, and a scale could be 100 meter, and instead of X property we will have system time start, the main variable helping us to plot the area variation for each existing year. And through the set chart type, you can convert the chart type from, for example, line chart to column chart. Run the code. In the console, you will have a chart that is generating that showing the area of each year clearly from the 9075, but its value is based on the square meter. And with a little change in the GHSL product, you will be able to convert the square meter to a square kilometer. For example, make a new variable GHSL number 2 equals to get the existing GHSL product, and then through the map make a new function, and each input element considered as an IMG. In this function we want to convert the pixel values to the, for example, from a square meter to a square kilometer. Just return each image divided to 1 million, 1 is 6, with the all properties, img dot property names. So now copy the GHSL number 2 instead of the previous one. A new chart will be created according to, you can see that created, and also with a new title, actually with a new unit. And if I open it up in the new browser, in the new tab, you will see that for 2018 we have very low number. That is a bug in the product. Maybe in future it will be corrected, I don't know, but in the time that I'm producing this product, it has this kind of error. Maybe for the other regions there is not such kind of errors, I don't know, and I didn't check. Only for the study area I have checked is Tehran and some other regions in Iran. But now you can see we have the area of residential pixels from the 1975 to 2030. That is very valuable, and you will be able to have access Excel file through the download CSV option here, that helping you to get the values in the Excel format and open it in the desktop softwares and Python programming language for the further analysis. I hope you liked this tutorial as much as we did, and you can find the code in the description part of this video in my YouTube page. And also, if you couldn't write this code and if you faced with any problems during the scripting in the Earth Engine platform, feel free to reach me out and put your comments. I will check it and answer as soon as possible. Thank you for your attention.